Let's look at 2023 WASSCE November question 7. Okay, a question on mensuration, that is on circle. Is it a chord AB of length 8 centimeters is drawn in a circle, center O. If the circle has a radius of 7.5 centimeters, find correct to one decimal place the A angle the chord subtend at the center O, B the length of the minor arc formed by the chord, C area of the I major sector AOB, II triangle AOB, II major segment formed by the chord. Okay, so with this question you have to draw a circle. Alright, so we will draw a circle neatly here. Okay, then we have a chord of length 8. Alright, so the chord is AB. So let's say this is our chord AB of length 8 centimeters. So the chord has length 8 centimeters. Alright. The chord AB is drawn in a circle center O. So the center of the circle is O. So let me join here to know the angle the chord subtends at the center. Alright. And then I'll get the radius too. If the circle has a radius of 7.5, so my radius is here. 7.5. My radius is here. 7.5. Alright. Find correct to one decimal place the A angle the chord subtends at the center O. So there is the chord. The angle the chord subtends will be here. So we don't know the angle. So we don't know the angle the chord subtends at the center. So what we are going to do, let's draw a perpendicular height to here, the length from O to the chord. Alright, and I think when we draw, we'll be able to calculate for the angle the chord subtends at center O. So this angle is what the question is actually talking about. Okay, so how are we going to find this particular angle here? So what will help us is, as we draw a line from the center O to the chord, we know when we learn from the chord, we know that the angle here will be divided into 2, and then the length of the chord will also be divided into 2. So here will be 4 centimeters, and here will also be 4 centimeters. So that 4 plus 4 will give me the 8. Okay, if that is the case, and what has happened here is that this triangle becomes the same as this triangle, right angle triangle, right angle triangle, because we know the length from the center to the chord is perpendicular to the chord. So 90 degrees is formed here. So this is a right angle, this is a right angle. And how do we find the angle here? So if you want to find the angle here, then let's say the angle here, let me call it as beta. Alright. So we can calculate the angle here, okay, beta, because the angle here is the same as the angle here. And note that this particular line will divide the angle into 2. So whatever angle we find here, when we multiply by the 2, we'll get the entire angle at the center of the circle. Alright, so if here is beta, here this side is opposite, and then here is 90, so this side is what? This side becomes what? Our hypotenuse. So we will use sine. So we say sine beta opposite. What is our opposite? 4 opposite over the hypotenuse. So our beta will be equal to sine inverse of 4 on 7.5. So sine inverse of 4 on 7.5. And we are going to get our beta. Our beta as 32.23, let's say 1 degrees. Okay, so 32.231 degrees. So that is our beta here. But the question says you should find the angle the chord subtends at the center. So whatever angle is here, when you multiply by 2, you get the entire angle here. But when you divide this angle by 2, that is what you get here. So therefore the angle the chord subtends at the center. Therefore, the angle the chord subtends at the center will be equal to 2 times 32.2231 degrees. So let's multiply by 2 and then we get to know our answer. So 2 times 32.231 degrees will give us 64.462 degrees to 1 decimal place. We're asked to correct to 1 decimal place, so that will give us 64.5 degrees. That is to 1 decimal place, 64.5 degrees. 64.5 degrees. So that is the angle at the center of the circle. All right. So let's go to the next question. Okay. B. Length of the minor arc formed by the chord. Length of the minor arc. Okay, so we have our chord here. And this chord, this arc here, okay, is the minor arc. And then the arc here, the bigger arc here, is what? Is the major arc. Okay, so we are finding the length of the chord formed by the minor arc. So we are talking about the length of this particular chord. All right, the length of the minor arc formed by the chord. So this is the minor arc. The major arc is here. All right. So let me put. We will need the angle to calculate for the minor arc. So let me put my theta. The angle theta is what? 64.462. Okay. You make sure you don't use the converted one so that your answer can be accurate. All right. So we are done with the A part. The length of the minor arc. So what is length of a minor arc? Length of a minor arc. An arc is what? It's a portion of the circumference of a circle. So the length of the minor arc is theta on 360 times 2 pi r times 2 pi r. So this is the length of the minor arc. Okay, the angle the arc subtends at the center divided by 360 times 2 pi r, which is the circumference of a circle. Okay, so when you visit our lesson on mensuration, all this have been taught there. Okay, so what is the angle at the center? That is 64.462 degrees over 360 times 2 times pi. We're giving pi as 22 over 7. 2 pi. Then what is our r? 7.5. All right, so you just put this on the calculator and then you get our answer. So 64.462 theta on 360 times 2 times pi, 22 on 7, times the radius 7.5, and that will give us 8.4415 centimeters. All right, so we were asked to correct to what? To 1 decimal place. So we are going to get 8.4 centimeters. That is to 1 decimal place. 8.4 centimeters. So this is the length of the minor arc. The C area of the major sector AOB. The major sector. So where is our major sector? Our major sector is here. Okay. Okay, so let's see our major sector. So this is our major sector. 7.5 centimeters, 7.5 centimeters. We have our center as O, and then our A and our B. Our major sector is here, and this part is the minor sector. All right, so it means that we need the angle the major sector subtends at what? At the center of the circle. So what is the area of a major sector, okay, or area of a sector in general? Theta on 360 times pi r squared, that is multiplied by the area of the circle, because a sector is a portion of the area of the circle. All right, so we need the angle at the what? At the center, the major sector substance at the center, divided by 3 times pi r squared. So what to be the angle? We know the angle here as what? As 64.462. So angle around the point is what? Is 360. So we are going to subtract it from 360. Then we divide by 360, then times the area of a circle, pi r squared. All right. I believe we get it. So area of the major sector AOB is what? 360 minus, so because the major sector is here, so we need the angle here as it was shown. Okay, so 360 minus 64.462 divided by 360 times pi r squared. Okay, pi r squared, so pi is 22/7 times the r squared. What is our r squared? 7.5 squared. 360 minus 64.462 will give us 295.538 divided by 360 times pi r squared. Okay, so now we can get our answer. So we have 295.538 divided by 360 times pi times 7.5 square. All right, pi r squared. That will give us 145.1303 centimeters squared. Okay, so because it is area, then I have to add what? Centimeters squared. All right, because it is area. So area of the major sector, but we're asked to correct to 1 decimal place, so that will be 145.1 centimeters squared. That is to 1 decimal place. That is to 1 decimal place. So this is the area of the major sector AOB, the major sector. Okay, so the next thing is we are asked to find the area of triangle AOB. Okay, so triangle AOB, BCII, triangle AOB. Okay, and what is area of a triangle? So from we know area of a triangle is half base times sides. Okay, but from the segment and then on the circle that we have learned, you said the area of a triangle is what? Of a triangle is the same as half r squared sine theta. Okay, half r squared sine of the angle. Okay, so the area of the triangle is the same as half times the adjacent. Okay, when you know two adjacent sides and there is an angle between them. All right, and I've proven that when we're doing the segment. All right, so you can watch on that and then we learn more on the area of the triangle. So half times 7.5 squared, 7.5, which is the radius, times sine of the angle. What is the angle? 64.462 degrees. So that is a half r squared sine theta. So that becomes the area of the triangle AOB. So half times 7.5 squared r squared times sine of 64.462. Okay, and that will give us 25.3772 centimeters squared. Okay, so this is the area of the triangle. This is the area of the triangle. All right, and we are asked to correct to 1 decimal place. So 25.4 centimeters squared. That is to 1 decimal place. 25.4 centimeters squared. Then we solve the last one. So the last one, major segment formed by the chord. The major segment. What is the major segment? There is the major segment. If for the chord is here, the down here is the minor segment, and then the top here, the triangle, and then the major sector here becomes what our major segment. So I area of the major segment. Area of the triangle or area of sector AOB plus triangle, area of triangle, what? Area of triangle AOB. All right. So the area of the major segment is area of sector AOB, this sector AOB, plus area of triangle AOB, this area of this particular triangle. All right. So what is the area of the sector AOB? Area of the major sector. All right. Is 145.1303 plus area of the triangle 25.3772. Okay. So take notes. The area of the major. The major sector plus the area of the triangle. So we are going to add the two. This is the major sector, this is the triangle. So 145.1303 plus 25.3772, and that will give us 170.5075 centimeters squared. All right. However, we are asked to correct our answer to 1 decimal place. So that will be 170.5 centimeters squared. That is to 1 decimal place. Okay. So this is our answer. So I know I will see you once again. Continue to revise and learn, and maths will be easy for you. Bye bye.